Hello and welcome to your instruction 1.4. In this instruction, we will look at Reaxys and how you will use this to access a whole host of literature like UV-Vis, IR, physical properties of your structures, and even use it to draw some of your structures. Maybe some of you used it in CMY 285, but this is a more formal introduction to it. And we'll also cover some aspects might have gotten lost in your second year, and I'll try to cover as much detail as possible in under 30 minutes. Okay, let's get started. Right, so the first thing that you would like, well, you should do is open up your web browser, and then you can go to your UP library. This is how you will find Reaxys, and the first link should be UP library. Go to the search tab, go to subject guides, and scroll down to chemistry in the alphabetical list. Then somewhere, either one of these, then you can go to Reaxys. You can see there's a bunch of interesting video tutorials on Reaxys that you can also watch for yourself if you're struggling with a few aspects of it. If this video is not sufficient, you can use these. But for now, click on that link, which will take you, or first you will have to sign in. If you're on the UP Wi-Fi, it will immediately just take you to the page. But if you're at home, you will need to sign in, and it will take you to a page like this. Okay. From here, now you'll be able to draw substances and search, or you will be able to type directly the name of a chemical substance and search articles or information, physical data, spectra, etc. on this. So let's use the draw function just because it's more intuitive for us. And let's say we want to draw our cobalt ACAC complex to start with, because that's what you're looking at in your first experiment. So cobalt is a D9 metal in its neutral form. So we'll start with that. And of course, this is an octahedral complex. So we want to draw some sort of octahedron. Doesn't really have to be perfectly drawn. Reaxys will understand exactly what you are drawing, but I'm going to go through this quite quickly because it can become a very lengthy video if I go through. I made a mistake. Can become a very lengthy video if I draw every little step of this. Essentially, you're going to draw the complex, and I take it that most of you should be able to draw the complex quite easily. That shouldn't be difficult for you. So here's your ligands. And then, of course, these are oxygen functionalities. So you need to change these atoms to oxygens. And they are doubly bonded here. And now you see Reaxys is complaining that the oxygen is bonded to more atoms than it should be. You fix that because this is actually a coordinate bond. So you see, if you click on this option here and you hover over this option, it says coordinate, and here you can change, just ensure that the oxygen coordinates to the cobalt, not the cobalt to the oxygen. Remember, whichever way is donating electronegativity or electrons. And there we have our ACAC complex. You can use these buttons to clean up your complex, but this is perfectly fine. Reaxys should find what we are looking for. Okay, so here we've drawn our ACAC complex, and let's transfer this to our query here at the bottom. All those buttons on the right hand side you can leave as is. Let me quickly you can leave these as is, don't worry about them. That just means we want to search it as drawn, no other things yet, no tautomers, no stereochemistry, nothing, just as we've drawn it. Transfer that to your search and click find. And then here on the first, let's view our results for substances. And this will take you to a page that looks like this. And here you can see you can find physical data on it. So melting point of your substance. You can look up the melting point. So you can see the melting point. Quite a number of varying melting points, but you can take an average of some of them or look at how many of them reported in a certain range, and then see, I usually take which one ever is the most recent. That's what I take, because of course our techniques have improved since 1952. For example, Also, you were interested in spectra, so there's IR spectroscopy. You can always just ensure that we run our things on a potassium bromide palette. So all the ones that says potassium bromide are of relevance to us. So you can see your bands there, and you have the references here on the right hand side. So it's for you to use. I will go through the referencing now in a split second. And of course, UV-Vis is also provided. And we did our UV-Vis in toluene. So our UV-Vis is collected in toluene. There's only one of them that is given in toluene. Some of these, it doesn't specify in which the UV-Vis was given. For example, it's 1914. So you can forget about that reference. But let's go to the one that says toluene. So here you can go to the full text, just there, in full text, and there you can go to the DUI. Remember, the DUI is like the website for a reference. Okay. And you don't have access immediately to it, so you can copy it, and then again you can go to the UP library. If you are on the Wi-Fi, it will be immediately be available. But if you are at home, go to the UP library, click on Google Scholar, paste the name of the article you're interested in, go to Google Scholar, click on that, say you want print text at UP. Sometimes it appears on the right-hand side over there. Then you will go to full text. I do know I'm going quite quickly, but you should have gone through this in second year at some stage with Miss van der Linde from the library. So this is more like a recap. And then we want to, can't remember where they said exactly this is. Oh, they said the location is the supporting information. So we're looking for the supporting information of this supplementary data. So there says Appendix A, supplementary data. And let's download the Word document. Let's open it. Now we'll scroll down to where we see some UV-Vis. Oh, there it is. Okay, so now you're going to look at the UV-Vis, and of course, it's probably going to be an estimation of where these peaks are, and then you will compare it to your UV-Vis that you have collected. Actually, see there's some FTIR as well included in this. So you've also collected some FTIR data. These are crystal structures. You don't have to be bothered with that. Let's see what else they have. They just have bond lengths and angles in there. Okay. So I hope this explains now how you will find your spectra and how you can use your literature spectra to compare. You can actually include this in your report if you would like. Remember just to reference it correctly. We'll go through referencing soon using Mendeley and other techniques. But in principle, this is how you will find some literature spectra for you. And then you can see it says UV-Vis in acetone, chloroform, methanol, there's the toluene. So UV-Vis spectra of cobalt Ac3, orange line. So let's zoom in on the orange line. I wonder what is the difference between these two. So this gives absorbance with wavelength. This is just a zoomed in version of that. Okay, that's important. So you need to analyze these things as such. So you see there's a peak, there's a peak, maybe there's a peak, slight dip, and there's definitely a peak. So you will need to discuss how it fits with our data. Not necessarily, remember, differences are possible. It's not the end of the world. Just remember to discuss them, say how they fit with it. Doesn't mean we necessarily did something wrong, just means there is a difference. Okay. Let's now move to the nitrated version. Okay, so let's go back. I would really want to save this. And let me just close. Oh, my goodness, can this stop popping up? Let's go back to this. So now I want to go back to my quick search. So of course, so you can access all the references now for whatever you would like to look at. So don't say new here, go to edit. So now you have your cobalt ACAC. So once you've accessed all the literature values and interesting information, your melting point, your IR, your UV-Vis for your cobalt ACAC complex, Now we want to look at the nitrated version. The reason I want to show you this is it's a very important aspect that you need to insert when drawing this. So our nitro group, of course, is bonded to two oxygens, NO2. I hope you understand this concept. And one of them is doubly bonded to the nitrogen as such. But now you see it says NH, NH, NH. The reason it does this is because, of course, the nitrogen has 4 bonds here. 1, 2, 3, 4. So to change that, right-click on your nitrogen, say Atom Properties, and make this a +1. Now you see this is gone. As well as that is an OH, and that shouldn't be an OH. So again, change that to -1. So see, in all, this is NO2, and that plus and minus cancels, and we just have an NO2 group. But this is in principle how the structure looks actually when you draw it out. Okay. Now I'm giving away some answers, but I know this is also something you will struggle with if I did not show it. And it's more important for me that you understand or be able to do certain aspects rather than just leaving you onto your own devices and you're not really learning anything. Okay, so now that you've done that, you have all your NO2 groups, all of them coordinated. So we have our nitrated version of our complex. Transfer again to query, again find. This time we see we only have a few hits. We're going to view the results. And whatever you get, you're always more than welcome to use that. So again, let's look at the spectra. Of course, your physical data, look at the melting points. There you can see this one is better defined. Your melting point, you might easier define it. And we're looking at IR, so potassium bromide, so they collected it between that range, so you can use that IR spectrum that they provide. And UV-Vis, unfortunately, they did theirs in chlorophyll. So let's again look at the full text. We see, okay, of course, we don't have access to this. So this is, I'm going to skip through this quite quickly. Scholar, paste, because I've already shown this now to you. So you can find your UV-Vis. They don't specify exactly where it is. For example, it's in supporting information or the actual reference, but okay, I think that is it. Electronic absorption spectrum of cobalt, whatever. So there we can see there's a peak, 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 peak. And then you can assign, you can compare that to our spectrum that we have obtained, we provide you with. All right, so of course read the article to completely understand what the article is about before you just use it. But unfortunately, they don't provide one in Toluene, but then you just say it is in chloroform, so any differences, of course, can arise from the different solvents used. You just see what's here in the other photoelectron spectrum. That's not really. Let's see what other spectra, ESR, no. Doesn't seem like there's any other option. Okay, but in general, that's how you will use Reaxys. And you will use you can use Reaxys right through the course, draw all your structures and find them. You can also search them by name, but sometimes you just have to check that the structure is correct. So let's say, for example, let me start from scratch. You go to draw and you say here, insert structure by name. And you go acetyl cobalt 3. You're going to see does not really give you what you're looking for. That is incorrect. This is a metal carbon bond, which is something you haven't done yet. You'll get to that when you do the ferrocene prac. And of course that's wrong. So you're not going to get the correct thing when you look up this. So just always be cognizant of what you're looking up versus what Reaxys actually puts in by name. So when you're entering the name, you might get some funky things here. Okay, so that's Reaxys in a nutshell. You can play around, and remember, as I said, in the library there is some videos for you. Unfortunately, research is a time-consuming process. So some of you might have thought to yourself, now goodness, this looks like a lot of work, because it is. That is the reality of the field you have chosen to put yourself in. You have to sift through a lot of articles, a lot of details, and always check. You need to read this article, and you're going to read the article essentially just to find out where the three peaks are, where this thing absorbs, essentially. It might even summarize it in a table somewhere, but you'll only find out that, I can see here it says DD transitions of the ligand field parameters. I mean, but you'll have to read this. It says cobalt 3 nitro ac. So read this. You'll have to find these things yourself, and that's part of the field you are in. So I hope Reaxys does make it easier for you to find it, though. But please use it as much as possible, and as long as you reference correctly and you state what you found, how you found it, and sort of compare it. Remember, if something is running chloroform versus you did it in toluene, or if both is in toluene and there's a difference or whatever, and you describe it well enough, you will get your marks, because I know that's all you're really concerned about at this stage. Essentially, don't worry too much about nitty-gritties. Just get from point A to point B, meaning that you got literature, you have yours, and you've compared them. Don't worry too much about discrepancies or whatnot. It's more about the process. We're interested in seeing you learn, and we're interested about seeing you develop as a scientist, more than we're interested in you getting the exact right answer. Okay. So yeah, as always, good luck, and thank you for watching.